Hi everyone, what's up? Welcome back to my tutorial channel. It's Daniela here, and today I'm going to talk about investment risk. In this video, I'm going to show you the 4 different investment risk measures, how to compute them, and I'm going to give you some properties of these measures. So first, let's take a look at the 4 different investment risk measures. In this lesson, we are going to explore 4 different risk measures. The first one is variance, and the variance is computed by ES squared subtract ES whole square. Variance is a familiar concept that we have learned in XMP, XMFM, in some probability courses, and also in statistics. So this is not a new concept. We all know how to compute variance if we have taken XMP and XMFM. So there's nothing I have to show you why we got this formula. Actually, for variance, we have 2 different formulas, but here I'm going to use the most convenient formula, that is ES squared subtract ES whole square. S here is the value of the variance, the value of the variable. The second concept is the semi-variance. This is a new concept we have not seen in XMP and XMFM. So I'm going to explain the formula a little bit. For semi-variance, we compare the deviation between the value of the risk with the mean and compare that with 0. So here, and we take the minimum, so if the deviation is positive, if the risk is greater than the average, then we are going to eliminate it. And we are going to just focus on the negative deviation. That means when the outcome is less than the average. That's why we have minimum between 0 and S subtract mu. And then we square this deviation and add all the deviation together to take the average. The third concept is value at risk. Value at risk is just the percentile. We just give it a fancy name, value at risk, but it's just the percentile of the distribution. For example, if in an exam, let's say exam, the GRE exam, we want to see who is the 95 percentile. So the 95 percentile is basically the student who got the score that is higher than 95% of the contestant and lower than the 5% of the contestant. So the value of risk is just a new name for the percentile. Here we use P between 0 and 1 because P is just like probability. So we use a notation VAR as a value at risk. 100 P% value at risk is basically the P percentile, so it should be F inverse of P. Here F is a cumulative probability distribution, and this equivalent to the cumulative distribution function at the value at risk is equal to P. Number 4, tail value at risk. When we know that the outcome is greater than the value at risk, we want to see how close the outcome and the value at risk is. So we are going to measure how bad the result can be, so we have to use the tail value at risk. Here the tail value at risk is basically the average of the tail. So we take the average of all the possible outcome that is greater than the value at risk. And here we consider continuous distribution. So we take the integral from the value of risk to infinity of x times fx dx divided by 1 minus p. So this is how we compute the tail value of risk. So these are the 4 different risk measures that I want to introduce today in order to measure the investment risk. Now we are going to work on group by group. The first two measures on this table are the measure of deviation because we take deviation in account. The last two are the measures of percentiles because we consider the percentiles in order to compute these two measures. Alright, so let's look at the first two measure of deviation, variance and semi-variance. Let S be the price of a stock 1 year from now. Suppose that we have the following probability distribution of S. So this is a random variable, right? Here we have 4 possible value of S. That means we have 4 possible value for the price of the stock 1 year from now with their probabilities. And we want to find the variance and the semi-variance. Here I use sigma square of S or sigma square of V, whichever, as the variance. And sigma square of SV is the semi-variance. So remember, in order to compute variance, we need to compute ES and ES squared. So let's compute the mean first. The mean here, the expected value, we basically take the weighted average. So we take its value of the possible value list times its probability and then add these numbers together. So we got 12, the first number times its probability upon 2. Then the second number 14.5 times its probability upon 25. The third number of 15.5 times its probability upon 35. And the last number is 17.75 times its probability. And add them together, we got the mean or the expected value of 15. Okay. Next, ES squared, 12 squared times 0.2 plus 14.5 squared times 0.25 plus 15.5 squared times 0.35 plus 17.75 squared times 0.2, and we got 228.4625. So we got ES and ES squared. Now we take ES squared subtract ES whole squared to get the variance. So the variance here is 228.4625 subtract 15 squared. 15 squared is around 225, so we got 3.4625 for the variance. So that is the first measure of deviation. Now we look at the semi-variance. For the semi-variance, we consider the negative deviation. So here, for the first group, the first number, we got 12 subtract mean of 15. We got -3. You see that? -3 is the first deviation. For the second group, we take 14.5 subtract 15. We got -0.5. That is the second deviation. The next group, we got 15.5 subtract 15, which is 0.5. This is a positive deviation. And the last group, we got 17.75 subtract 15 is 2.75. This is a positive deviation. And when we consider positive deviation, we see the minimum between 0 and the positive deviation is of course 0. So for the last two group, we got 0. You see that? That means these two groups are eliminated. So we basically wipe out the positive deviation. Now for the negative deviation, we got the minimum between 0 and -3 is -3. The -3 squared is 9. See that? The minimum between 0 and -0.5 is -0.5. Then square we got 0.25. So we got 0.2 times 9 plus 0.25 times 0.25. The last two are just 0. We can ignore that. So the final answer is 1.8625. This is the semi-variance. See that? So here we have the semi-variance. That means we should consider only the negative deviation. For the variance, we consider both positive and negative deviation. But here we consider only the negative deviation. Alright. Now we look at the last two, value at risk and tail value at risk. Now we discuss about the two risk measures that relate to percentiles. We assume that the underlying risk is modeled by a continuous random variable x that with a cumulative distribution function CDF, capital F x of little x is equal to probability that x less than or equal to x. If you are in statistics or probability, you should know these, right? This is the cumulative distribution function for a continuous distribution. Now the value at risk is the percentile. Here, if I use p between 0 and 1, let's say 0.1, then we have to find a 10 percentile. So I take 0.1 times 100 to get the percentile. So we got this percentile separate the 100p% lowest from the 100 times 1 minus p% upper. For example, the 10 percentile separate the 10% lowest from the 90% upper. The 95 percentile separates the lowest 95% with the upper 5%. So we basically take the inverse of the cumulative distribution function at the value of p. For example, if we consider a standard normal distribution with the mean, remember standard normal distribution has mean 0 and variance 1. So the 50 percentile is 0. Remember, for standard normal distribution is symmetric, bell shape. So the 50 percentile is basically the number that separates the lowest 50 and the upper 50. So it should be right at the middle, right at the center. So the 50 percentile for standard deviation should be, for standard normal distribution should be 0. And the 95 percentile is 1.65. We can use the Z table to figure it out. But we all know 95 percentile of standard normal distribution is 1.65. Now let's look at the tail value at risk, or the tail risk. This tail risk tells us how the outcome is more extreme than the value at risk, how bad the result of a project would be. So we basically take the average of the tail. So it should be 1/1 minus p times with the integral from variance at risk, the value at risk, to infinity of x times fx dx. Alright, so let's look at this example. The returns of an investment follow a normal distribution with mean 7.5% and a standard deviation of 35%. Find the 10% value at risk, so p is 0.1, right? Now here we got R is the returns. R follow normal distribution with mean 0.075, standard deviation 0.35. So by standardization, we got Z is equal to R subtract 0.075 over 0.35. Z follows standard normal distribution and 0.1. And remember the 10 percentile of the standard normal distribution is negative 1.28155. This number can be found on the Z table. Then we got, by the standardization, we got 10% value at risk of this investment should be, we take negative 1.28.55 times the standard deviation of 0.35 plus the mean 0.075, and we got negative 0.3754. This is the 10% value of risk of this returns of investment. And the tail value at risk is, we calculate the average of the tail from negative 37.54 to infinity of 1/1 minus p, so it's 1/0.9 time with x time with the distribution. Here the distribution of this is 1/square root of 2 pi times sigma square, which is 0.35 square, e to the negative x minus 0.75 whole square over 2. See that? So this is how we calculate the tail value at risk. Now for any constant, we are going to shift this to the front. So I shift 1/0.9 and 1/square root of 2 pi 0.35 square to the front. And then I assign a new variables. Let's say u is equal to x minus 0.07, u is equal to x minus 0.0075. Then u is from negative 0.4504 to infinity, because we take negative 3754, subtract 0.075, and we got the lower bound here is negative 0.4504 to infinity. And we separate them into two different integrals. One is u e to the negative u squared over 2 du, and the second one is 0.075 e to the negative u squared over 2 du. Just derive this on the paper, you will get the same result. Okay. Now we evaluate these two integration. The first one, we should got negative e to the negative u squared over 2, go from negative 0.4504 to infinity, and we got e to the negative 0.01 to negative e to the negative 0.1014 is the value of the first integral. And for the second integral, if we add 1 over, if we times 1 over square root of 2 pi, then we would have the distribution of the standard normal distribution. So this is equal to square root of 2 pi times 0.075 times probability that z is greater than negative 0.4504, where z here is the standard normal variable. And we use the z table. We got 0.6738 is the probability that z is greater or equal to negative 0.4504, and substitute in this, we got the final answer is 1.3048. 1.3048. So the tail value at risk is 1.3048. See that? So I have gone over the 4 different risk measures and how to compute them. Now we consider the probabilities of the risk measure. We have 4 main probabilities of risk measures. The first one is translational invariance. G of x plus c is equal to t of x plus c. G of x minus c is equal to t of x minus c. The positive homogeneity is g of c times x is equal to c times g of x, where c is a positive constant. Subadditivity, we got g of x plus y is less than or equal to g of x plus g of y. And the monotonicity, if x less than or equal to y for all the possible outcomes, then g of x less than or equal to g of y. That means you know that the higher outcome, the higher risk, right? Now for these 4 measures, let's consider these 4 properties. The first measure is variance, and for variance there's no translational invariance property, no positive homogeneity, no subadditivity, and no monotonicity. Semi-variance, none of these. For the value at risk, we got translational invariance, positive homogeneity, and monotonicity. For the tail value of risk, we got all of these 4 properties. All right. So that's all for today. And now we are going to do some practice, but keep in mind that the following exercises are just core examples. In order to have the best practice, please find and work on more exercises that relate to this topic. Let's look at the first problem. The return on a stock R follows a standard normal distribution. Find the semi-variance of R. So here we got R follows standard normal distribution. So the probability, the density function should be 1 over square root of 2 pi exp of minus R squared over 2. The mean of R is 0 because this is standard normal distribution. So the semi-variance of the semi-variance is expected value of the minimum between 0 and R's whole square. because the mean here is 0, so r subtract 0 is just r. See that? So we are going to use integration to evaluate this x value. So we got integration between negative infinity to infinity of minimum between 0 and r whole square times with the density function. And don't forget that for semi-variance we focus on the negative deviation. So the positive deviation will disappear. That's why we have the narrowed integration from negative infinity to 0 instead of infinity, because from 0 to infinity we got positive deviation and they disappear. So now we got a new integral from negative infinity to 0 of r squared times with the density function 1 over square root of 2 pi times e to the negative r squared over 2 dr. This is standard normal distribution density function. And now let's do the integration for this. Here we separate 1r. From r squared we separate 1r on the front and 1r in the d, because d of r squared over 2 is r. So d of r squared over 2 is only 1r. So we should need only 1r in the front. See that? And this is equal to negative infinity integral from negative infinity to 0 of r times 1 over square root of 2 pi d e to the negative r squared over 2. Because d of e to the negative r squared over 2 is e to the negative r squared over 2 times with negative r. So we flip the negative side in the front. And we got negative 1 over square root of 2 pi times r e to the negative r squared over 2 from negative infinity to 0, plus negative infinity to 0 of 1 over square root of 2 pi e to the negative r squared over 2 dr. The last term is the probability that r less than 0, and the front should be 0. The front should be 0. So finally we got the semi-variance of this is 1/2. And one thing we can notice here is, remember for standard normal distribution we got variance is 1, right? And then we got semi-variance is 1/2. This is a beautiful answer. Question number 2. You obtain the following sample profit. Estimate the semi-variance of the profit. So here, first the sample mean is 0.9823, right? This is easy to be calculated. We take the average of these numbers, and now we find the deviation by take each of these numbers, subtract the mean. So for the first number we got negative 0.52113. The second number give negative 0.7813. The next number yield negative 0.7583, and so on. Now we are going to focus on the negative deviation, because the positive deviation are not necessarily eliminated. So we got 1, 2, 3, 4, 5, 6 negative numbers. So we square these 6 negative numbers and add them together, then divide by 10, because we got 10 number on the list. So the sample semi-variance is 0.2593. See that? So after finish this lesson, we should be able to explain the investment risk measures, understand the risk measure of deviation like variance and semi-variance, understand the risk measure of percentiles, and understand the properties of risk measures. So that's all for today. Thanks so much for watching my video. I hope you guys find my video helpful, and bye.